Well, hi everybody, I'm back. It's been a little while. I took a break for a good month while I worked on a bunch of other projects that simply had to get done, maintenance and things. And so I had to put this car aside for a little while, but it's back on the rack now and I'm able to work on it again. And so it's time. Spring is coming like a freight train. I got to get this car done. So when I left you all, I was in the middle of the oiling system. I've gotten ahead of you a little bit on some things. And so I'm going to explain what I did and why. And when I left off, I was on the oiling system. And you can see a few things here. Don't mind this wiring right now. Just ignore that. We'll get to that in just a little bit. That's just on the way. So anyway, let me walk you through a little bit on the oiling system and the plumbing, since that's now done. Okay? Handheld time. I hope I'm not too shaky. Anyway, so the first thing I had to do was the power steering pump reservoir had to be connected. And it's very simple. It goes from the pump down to the rack, from the rack back into the bottom of the reservoir, and from the reservoir back to the pump. Can't get much simpler than that. So that's all that needed. The oiling system for the dry sump starts at the pump down here, at this dry sump pump, and the evacuation line from the pan comes out of this pump, goes back to my reservoir in the car there. The reservoir goes in the top, and then comes back out the bottom, other big line, and goes in the bottom front of the motor to the original pump, which will suck it up and put it in the motor. If it was a standard dry sump system, there'd be another stage on the back of this pump just for pressure, and that line would go to that and then into the motor, okay? And we'll take a look on the underside then, okay? Right. On the underside, we've got our lines here are the suction lines on each side. These are the two that go to our pump up here and then feed that tank. The return line is here coming back in the motor. That's pretty much the system. There's another deal here. This is my remote oil filter adapter. It simply goes out up there to my oil filter and then back into the engine. And that's all there is to it. When you first see a dry sump system, I know it's really intimidating. But once you do it a few times, it's really not that bad. We're just pulling the oil out here and pumping it back in here, and that's about it. So that's all of that. We got our AN fittings on our power steering lines, and all of that is hooked up, so we are good to go. So that takes care of that. So remote oil filter. In can come in either side. This one's blocked. Comes in here, out, or in the top here, and out the ends here, and I've got a gauge on it. That takes care of it. So yeah, the in is in the center, the outs are on the outside. So that's pretty much all there is to that. Very simple, remote mounted. That way it's easy to change oil, and this isn't hanging down under the car, okay? So now let's move on to the cooling system. Next order of business was mounting the radiator. The thing was, it was not going to mount behind the bulkhead where it normally would be, because that's where the accessory drives are for this engine, and we knew starting from the beginning that this was not going to fit back there. Not going to happen. So it was going to have to sit in front of the radiator bulkhead. And that puts us out here where we're sitting. And the first thing you have to decide is which direction, where, how high, how far forward, and all of that. And to do that, we want the radiator as high as possible and as close as possible. We want it not stick out any more than it has to, and I want it as high as it can be so I don't damage the lower radiator tank. And also, for air bleed, the upper tank, I'm trying to get it as high as I can for air bleed. And the radiator cap is actually sitting just behind the edge of the hood here. So I set the hood on and figured how high I could pick it up without hitting the hood right here. And that radiator cap is right there. So this is as high as I can get it. So I blocked it up here and held it here and said, okay, hung it from some tie wraps and took a look at this is where it's going to have to sit. I did have to make a little notch on this side. Let me show you that. This is a nice Mishimoto aluminum radiator from the Subaru. She's a sweetheart. I really wanted to reuse it. It's kind of expensive. Why replace it? It's a good radiator. And there's nothing wrong with it. But the outlet is up here. The inlet, actually, for the radiator is up in this corner. And the outlet is way down in the opposite corner. And this outlet here has to come from the engine. And so this bulkhead was in the way. And I had to actually notch it with a nibbler a little bit right around here to push it as far to the passenger side as I could get it, because I'm trying to center the radiator up in the car, among other things. So by rounding that notch a little bit, I was able to shove it over enough to get it within about a 1/4 inch of center in the car. So that was the first thing, to get it over far enough without lifting it any more than I already have. All right, now, to hold it up, the first thing I want to do is get underneath to hold it up. That was the first thing. So let me show you that. Well, the radiator has these studs sticking out, just pins, top and bottom, and they go into a rubber grommet. You never ever want to hard mount a radiator. If you solid mount it without any rubber isolation, you will crack the tanks, the mounts will break off, you will have tons of trouble. Never solid mount a radiator. So these little brackets are actually from the top side. So these brackets hold the rubber mounting, and they can hold the radiator up, okay? They're not terribly strong. They're meant for the top. They're not to support the weight necessarily, but they are strong enough, and there's going to be more. Hang on. So what I had to do is put these under here and come up with a bracket to the chassis. I thought of all kinds of pieces of tubing and things, and finally just came up with a piece of round tube welded to the core support with a tab on the end that was threaded for a bolt, and used these tabs to hold it up. So this is quite solid and holds it up. But this will be getting additional support. Later, there's going to be a skid plate under here. And the skid plate will have rubber bumpers on it, which are also going to take part of the load of this radiator. And between these two, that will easily support the radiator. What it is now probably can, but having those rubber bumpers on the skid plate up under the front here will protect this, because yes, it's lower than I'd like it to be, but also that will also aid in supporting the radiator. So that got me to the point where I'm now up where I have to be. So now it's back to the tubes and hoses, which are loads of fun. Let me show you that. I will say over here on this side, we've got the outlet coming out here on the bottom right. It has to go under the frame rail or under the radiator core support and up to the input of the water pump. So this is actually just a 90 right angle. And what I usually do is I get hoses, and what I'll do is kind of measure everything and figure what angles I need, then go down to the parts store where I know everybody, and they let me just wander through the racks. And I pick through the racks and find things that I think are close enough with the right diameters, and I can cut sections out of them or use them whole, whichever. Most of the time you have to do sections because you can't get what you want to go all the way where you want it to. But I then write those part numbers down when you get them, because later you'll never want to go through that again. So when you finally figure out which hoses you're using and which parts of hoses, write the numbers down somewhere. Make sure you can find them. Okay? So let me go back up top. Upper radiator mounting. That's what's next. So the next thing was to get the top of the tank. And I looked at the studs and the isolators and trying to get back in here, and it really wasn't being very cooperative. This tank has several of these nice bosses on here that are threaded that are used to hold the fans. At the bottom, I'm holding it up. All I have to do here is keep it from moving in and out pretty much. That's the whole idea. So I came off of those with this little plate here. And you may notice it's actually two plates. I have a lot of this material laying around. It was the weekend, so I used a pair to get enough strength, but I'll probably replace that with a single piece. However, it's relatively simple. Just a flat piece here bolted to that radiator support, and then where it attaches to the bulkhead support here, I use vibration isolators. That's these little things. I get these from McMaster Car. They're very simple. They're rubber, and they come with studs on each side. You can get different thicknesses and diameters and widths. You can get them with threads inside or studs outside. I like the studs, makes life easy. And I have a pair of those, one here and one here, bolted into this upper core support. And that gives me my support for, won't rock in and out, and also locks it in up and down, won't go anywhere. So more support, very simple mounting arrangement. Had to notch it a little for one of those other bosses, but that's it. That's all I had to do there. So that gets this mounted. These are handy. I use them on a lot of things. I will be using those also to mount electrical components that I don't want vibrating, like the computer. Okay, so next thing was radiator hoses I was mentioning. So on this engine, it's really strange. Corvette water pumps are really bizarre. The water outlet is right here, and the water inlet is right underneath it for the water pump, which is located right here. So it's way up high, and I have to get from here down to there. And so to do that, long rubber hose, very difficult, and in most cases I like using hard lines with rubber on each end, which is what I did here. I'll try to get you a look in the back here, okay? What I've got is that 90 coming up from below, and I've got this nice aluminum tube that I had around, 1.5 inch diameter. Interestingly, the inlets on the engine are 1 3/8, so I had to have adapter hoses. But this hose right here, this solid line, then I anchored with a rubber line clamp and goes across, and then it hooks up with a rubber hose and has to make a hard right into that water inlet there. Man, that is a tight move. One of the problems back here was there was a core support right in the middle, and that had to go away. That used to support the hood latch right in the middle here. And because of the fact that I'm going to use hood pins, I don't need the hood latch, that was going away anyway. So I was able to get rid of that vertical support down the center here. I cut that out. And so that took care of that part. Over here, where this water outlet comes, you see how close it is. And what I had to do is notch this with a nibbler on this upper support. Now this support is removable. What I did was I cut it here and over here, and I welded in a plate of metal underneath here to this side, and then tapped it on this side so I could put bolts in. So now this can be bolted in place and removed in and out. It was easy for getting the engine in and out, and it's really helpful. But I got a nice big solid plate underneath here that bolts into, and this is welded to. Did that on both sides. Again, I had to nibble that out. And then this little guy here, this is important. This is a steam line. So the deal is, this is the highest place on this engine where the steam can escape or air can escape, because you've got to bleed the system, get all the air out of the system. On the older LS motors, they had a whole steam passage system on the heads, and on the LTs, apparently, they followed this idea. So this has to go up to the highest point in the system. Unfortunately for me, normally that would go to my radiator cap, which is lower, not going to work. So to make all this work, I had to come up with another arrangement. And that means that this and this have to go to an expansion tank, or a tank that has a pressure cap on it. And lo and behold, the Subaru has such a thing. Subaru has this nice little tank with a pressure cap on it. And it has several ports and things I can use. This goes to a reservoir for the recovery, which I may still use. And it has a port out the bottom and 2 ports up top here. These are, the steam can go in here for bleeding, and the water comes out the bottom here. So when I bleed this system, this water will come out the bottom and the air will come out the top into this tank. I routed that back around here, and I'm still waiting on a couple of joiners to come in. These hoses get joined together right here. So that comes around here, and that goes back to that point. And so I just got to put a joiner in there. And then on the other side, on the bottom, I ran this out. I actually had a molded hose that would go out, come along here, up underneath here, and around, and hook up to my radiator cap here. Now, the problem is this radiator cap is a pressure cap. So naturally, the trouble is, until the pressure builds up, it wouldn't let the air out, and I couldn't have that. I've got a pressure cap over there, so this one doesn't have to be a pressure cap. So I modified it. And what I did was I took a grinder and I knocked off the little valve here that was a one-way valve, a check valve. So now air can bleed from here to here, and there's still a rubber seal up top. So that is going to allow the air to escape from here up there without having to overcome the pressure. And all of the equalization will be done up here in this tank. So that gets my water system installed. So just waiting on that little joiner, and that'll be done. So there is that. The fans are mounted on the front side. They're as low profile as I can get. That goes into a whole deal with the computer, because the computer runs a variable speed set of fans that are very expensive and are deeper and won't fit. I got enough trouble with the bumper. I'm not going to do that. These things will be protected up front here, by the way. There'll be a protection bar system up here to keep this all from getting damaged. So now that that's done, I'm on to the next great part of the project. The next great part of the project is wiring. Along with that is the fuel system, because they're integrated, as is everything on these engines. So I'm working on that right now. One thing I like to do is get rid of all the connectors I'm not going to use, and there are quite a few. There are quite a few. I don't have an automatic transmission, but I will have to have a controller. I don't have any air conditioning or heating and ventilating or body control modules. All of that's gone. So I can get rid of quite a bit of that. A lot of it's not on this harness. However, on this harness was a fuse block connector and a body control connector and some other things. So what I do usually is I de-pin them, pull these out, and I mark them. I got these nice little wire tags that you can write on. And you can write on here what the function is. And I wrote the function and the circuit number on each of these little tags for reference. So each of these from my diagrams use all data, and all data do it yourself, DIY. And there's a charge for it, but it's worth it. The diagrams have OE diagrams as well as aftermarket color-coded diagrams that you can click on a circuit and it highlights everything in it. Really handy. So I use all data, and I'm able to number the circuits, and I'm able to write down what their function is so I know who's going where down the line. Okay. The computer is going to sit up in this corner where it did originally in the other engine bay, and I'm going to go ahead and rubber mount this as well, obviously. So that's going to sit up in the corner here, and all of this wiring has to be dealt with. I'll get into a lot more of that later. I've heard various things from various people on it, and one of the things is the fuel system. So the fuel pump has to be able to provide about 72 psi to the injector pump, and that comes from the tank. Well, the factory uses a returnless system. That means it has one line coming out of the pump to here, and that's it. And with that, what they do is they vary the speed of the pump. Variable speed, pulse width modulated, PWM you might hear. That is a variable speed pump, and they have a module that controls that, that's talked to by this computer. Now this computer also reads the fuel pressure, so you have a special fuel pressure sending unit that has to go in line between that and the engine up here. So between the fuel pump and the engine, and it reads the pressure and then varies, it closes the loop on it. Well, you have to have that pressure sensor, and I hear it's supposed to be mounted vertically, and it matters. Well anyway, got one of those on the way. But that has to get installed along with a filter and some other things before I get too far along. The pump, question is, do you run the factory pump like that with that closed loop system? Most people say yes, you need to, you have to. The guy I'm talking to, I'll allude to later, he's telling me he's built a lot of these and they don't have to have it. You can, it's not necessary. And you can run a regular pump like an Aeromotive 340 pump that's in the tank, which is what I plan to do, is replace this old ugly scuzzy thing in here with that Aeromotive pump back out and bring it up here. So that is the plan, and then run a regulator up here. So I'll run a fuel pressure regulator up here that's going to be in that 72 psi range, and it will return to the tank using a return line. And then I'll measure the pressure after that using that sensor, which will feed the computer. And according to him, that works. Doesn't have a problem with it. Some other people said, no, it won't idle right, but he says it has to do with the transmission control module. Again, more on that later. So I am getting a transmission control module to let it know that it's not running at 157 miles an hour all the time, and thus making it rich at idle and screwing everything up. You have to have some sort of a speed feedback. Even if you just tell it it's not moving at all, it's better. So I said you have to have that. And so all the wiring is coming along. I've got a fuse block, a nice little busman unit. Let me grab that up. And that is this little guy here. And these are real handy. I grabbed it off another harness I had. It has 5 relays and 10 fuses. And I can use this for whatever I want. MetroPack connectors on the back. Works great. One thing I was warned about is the amount of pressure, or the amount of amperage that these systems draw tends to overheat the relays, particularly when they're in a sealed box. So I'm getting a different relay just for the main engine control relay that'll handle all that and not overheat. And then I'll run everything else here. Inside the car, I'll be running my favorite little switch box. This is going to sit between the seats. And what this does is it has my ignition and my start, and then I have 4 accessory switches for the fan to cool me off, or for the windshield, set of headlights, and anything else I might want. So these are handy little switches, and I got a nice box that I get from Mauser Electronics, and cord grips coming out the back to keep it watertight so that I can wash the inside of the car and this thing get wet and it's not going to hurt anything. These all have seals on them. So that's the plan down the road for that. So the next step is going to be getting into all the wiring and all of that. After that, intake manifold mods and we're ready to fire this thing up. There's some things that have to do with VIN numbers. I've got to get the VIN number off of this computer to have it burned into the transmission control module to match up. And I'll go into some more detail about some of the wiring, why, what, and wherefore, as I move along into that. So at this point, that's where I'm stopping at the moment. I'm getting into all that, and I'm waiting for parts to come in. So as soon as they come in, I will continue. But this is kind of an update. Hope that helps you out. Moving along, this thing is coming along. It's got to go racing. I got to get this thing done. So anyway, thanks again. This is Chapter 11. Frankaru will live again.